So yeah, last week we had talked about finding confidence intervals for means, right? So we were estimating, instead of estimating P, we were estimating mu, right? And so this time we are going to be talking about proportions and constructing confidence intervals for proportions. And so what that means is that our confidence intervals, the numbers in them, are going to represent percentages, right? Every single time. And so this section is different from 7.2 because if you think about it, if you're estimating a mean, that means the variable that you're estimating that mean for has to be a quantitative variable. But if you're estimating a proportion, you're estimating the proportion of people that gave you a certain response. That's not necessarily a number, right? So this is typically for categorical or qualitative variables. And so real quick, let's just put a little note up here. So if you're estimating mu, then you're estimating it for a quantitative variable. But if you're estimating P, you're dealing with a qualitative or categorical variable. So either one is a correct term for it, categorical variable. And so real quick, I'm gonna start here. So let me see if I can find an example. Okay, so yeah, if I scroll down, I'm gonna scroll down real quick. I'll scroll back up. But if I go to page 3, the example is, suppose that 800 students were selected at random and they were given shots to prevent a certain type of a flu. And so the variable that we're interested in here is, did they get the flu or did they not get the flu, right? Which is a qualitative variable. But when I was talking about confidence intervals for means, we were talking about things like heights, which is a quantitative variable. Or what was some other things? We were like, I think like number of years that somebody was in school or something like that, right? So it's always quantitative variables when you're estimating mu. And so that's one way that you can determine if you're estimating mu or P. So if you're having a lot of trouble figuring out if you're dealing with mu or if you're dealing with P, you can ask yourself if the variable in question is quantitative or qualitative, and then you can just look at this, right? So that's one way of figuring out which variable you want to estimate. And then, so let's start looking at these definitions. These definitions are basically the same as what we had for means, right? So the very first definition that we're going to talk about is the point estimate. Oops. And so the point estimates, remember? So we're going to have 2 this time. So what's the point estimate for mu? So mu's point estimate, what is that? Do you guys remember?
X bar?
Yes, X bar, right? Where mu is the parameter. Oops, hang on, that's not going to fit there. Parameter. And then X bar is the statistic, right? So those are definitions you absolutely have to know. And a lot of people got that wrong on the last exam. So make sure before you retake that exam that you understand the difference between those two things, right? But okay, so anyway, here, the point estimates. So what you're estimating is you're estimating Q. And remember, Q is the probability, or P, and P is the probability of success, where Q is the probability of failure, right? So this is chapter 5 review from stats 1201. So this is probability of failure, right? So if you're estimating one, then you're technically estimating the other as well, right? Because remember, do you guys remember what Q is equal to in terms of P? Actually, we're going to write it down right here. So let's say I tell you that the probability of success of it raining is 30%. What's the probability of failure?
70%?
Yeah, 70%. So remember, Q is just 1 minus P or 100% minus P, depending on if you're given a percentage or a decimal. But so here, since this is what we're trying to estimate, this is what we need point estimates for. So our point estimate for P is going to be P hat, and the point estimate for Q is going to be Q hat. We've already seen these variables before, right? So remember, P is the parameter and P hat is the statistic, right? So the point estimate is always the sample statistic, so it's going to be P hat in this case. And remember, so I had gone over this and I think quite a few times before the coronavirus hit and we had to go online and you had to watch me lecture from my house. But remember, P hat is equal to X over N. So you guys all remember me doing this on the whiteboard back when we could see people in person. And so like
Yes.
yeah, so this was the one where it was either you're either going to be given P hat or you're going to be given X. And so if you're given P hat, you can find X by doing N times P hat, right? But so yeah, don't forget about that kind of conversion. And then Q hat is just going to be 1 minus P hat, right? Or 100% minus P hat. But P hat should usually be written as a decimal, right? So you're typically going to end up using this one. But, oh yeah, and then so here, remember that X is the number of individuals that responded positively, or really what we had used, like rather than the word positively, so I'll put positively and then in parentheses, it was the number of successes, right? If you remember that back from chapter 5 in stats 1201. And then N is the total number of individuals, so or the sample size. Okay, so any questions so far? So if I kind of relate this back to 7.2, last time we were estimating mu. Oh, here, I'll use the highlighter. So last time we were estimating mu and we were using the point estimate of X bar. And so the only difference this time is that we're estimating P with a point estimate of P hat. And so you're basically going to solve all of these the same way by finding a margin of error and adding that and subtracting that to your point estimate to find your confidence interval. So the process doesn't change too much. It's just your variables that change. And then the thing you input into your calculator. So yeah, any questions so far? Okay. So then let's talk about the requirements that you need to check before you construct your confidence intervals. So everybody, all at once at the same time, what kind of sample do you think we need to have? Yes, I hope you all sat there in your rooms and said random out loud. So yeah, the data must be from a simple random sample. And then what we're going to check for here is what we had talked about in chapter 6. So this is coming from section 6.5. This is, remember, this is the central limit theorem. So this comes from the central limit theorem for P hat. And so what you're going to do is you need to check that N times P hat and N times Q hat. Do you guys remember what number we want both of those to be bigger than?
30.
not 30. That's if you're dealing with x bar and mu. But when you're dealing with p, what number is it? Oh yeah, it's 10, right? So I guess you could use 30. You're just giving yourself more restrictions. But for the problems, we're going to focus on 10. And so this basically means that at least 10 people responded positively and at least 10 people responded negatively, right? And then, so yeah, are there any questions about just the definitions and the requirements and stuff like that? So these requirements for constructing a confidence interval for p hat look exactly like the requirements for hypothesis testing for p hat, or for p technically. And so those two problems kind of start out the same, so it's going to be a little bit easy to get them mixed up. So when you're doing your confidence interval homework and quiz this week, look at the differences between that and the hypothesis testing that you should be studying for, right? And kind of look at the similarities too, because that's going to help you, that's going to get you set up for next week a little bit. So if we go and we look at this example, so a random sample of 188 students at a large cafeteria showed that 66 chose the vegetarian option. So P is going to represent the proportion of students who select the vegetarian option. And it wants us to find the point estimates for P and Q. So in other words, we have to find P hat and we have to find Q hat. So what is P hat going to be? What variable does this 188 represent?
P.
That's not P. So remember, P is a percentage or a decimal. And so P should either be between 0% and 100%. And since this isn't a percentage, it's not representing P. If it's given to you as a decimal, it needs to be between 0 and 1. This is also not X. So we have two numbers. Oh, go ahead.
Is it mu?
Not mu. So we're not going to be having mu anywhere in this section. So whenever you have P, you kind of forget about mu. So if you look up here, so P hat is equal to X over N. So those are the three variables that we really care about. So we have two numbers here. It can either be N, X, or P hat. So which number do you think this one is?
N.
Yes, that's going to be the total number of people that were in the sample. So what does that make X? Or 66, I said it.
X.
Yeah, that's X. Which means P hat then, which is X over N, is equal to 66 over 188. And when you do that, you're going to get, oh, you can't see the result, 0.35 if I round it to do 2 decimal places. So then Q hat, if I just look, so that one, I don't have to worry about which variables I'm given. I just have to find P hat first. And so I'm going to do 1 minus P hat, which is equal to, so 1 minus 0.35. Oh, where'd it go? Not 61, 1. Just point, so this is 1 minus 0.35, and so it's going to be 0.65. So yeah, any questions about part A here? And then I'm going to do part B really quick. We only have a minute left. But here you want to check that N times P hat is greater than 10. N times P hat is going to be 188 times 0.35, which is going to equal 66. Because remember, X is equal to N times P hat. Then you also want to check that N times Q hat is greater than 10. And so you're going to have 188 times 0.65, which is going to equal 122, which is greater than or equal to 10. So since these two numbers are both greater than or equal to 10, yes, the requirements are satisfied. Oh wait, I forgot a requirement. Which one did I forget?
Random.
Yeah. So I also need to say, yes, it's random. All right, so do you guys have any questions about this first page? I think what I'm gonna do is, and so hang on, let me stop this recording because this is not about the notes anymore.